Hello everybody, this is Dr. Nur Badshah. Today's lecture is about sampling techniques. In last lecture and last video, I discussed the population and data collection techniques, and the next step is obviously analysis, statistical analysis, sampling. So the first question is, why do we teach sampling? What is the importance of sampling in statistics? Usually the population would be large, or the population is large, and it's very hard to analyze or to do any calculation about it. And therefore a small part of the population is taken for doing some calculations and to do some analysis, and that small part is known as sample, which can be done in a systematic way. So the sample basically reflects the characteristics of the population from which it is drawn, and it is also reducing the bias in the data as well. And we do measurements in sample because it's easy to do it, and then we make conclusion about the entire population, and obviously it's very feasible as well. How do we do that? What's the basic concept in doing sampling? We'll be having a target population, and then we select some part of that population, is termed as sampling population, which is obviously optional. If you don't do this part, the sampling population, it's also okay. You can take directly, you can pick directly sample from the target population as well. For example, if you talk about average CGPA of students in a certain university, so the university will be considered as a target population. And then if you say, let's suppose a science building in the university, or engineering building in the university, may be taken as a sampling population, and from that building we may select one department or maybe one faculty, and from which you will be picking or taking a sample. So you can obviously ignore the intermediate step as well, which is a sampling population. Now, what are the main techniques used for sampling? So the first one, the easy one, is known as random sampling. The second one is known as stratified sampling. The third one is systematic sampling. The fourth one used for doing sampling is the cluster one, whereas we can do sampling in multi-stages as well. So let me explain these techniques one by one. How do we do random sampling? So in random sampling, every data point has an equal opportunity to be selected, equal chance of selection, and this can be done in different way. We can use lottery method, how do we do in lottery, and we can do that table of random numbers as well. That means that you would simply write names of the data points or number codes of the data points on piece of papers, and they fold those papers and put in a box, and then selecting a certain number of those piece of papers. If you are interested in a sample of size 10, so you will pick 10 pieces from it, and then the observation written, or the data points on the sample on the page will be considered as the sample, and that's obviously done as randomly. Or you may simply go for class number 1 is selected, class number 10 is selected, class number 15 is selected, class number 16 is selected, class number 20 is selected, and so on. You can simply call the class roles as well, or you can call them codes as well, that this number and this numbers are selected. So that is known as a random sampling. So what are the advantages? So the main advantage of random sampling is it is a most representative group, because you are selecting individuals spread over the complete population, and every observation would have an equal opportunity to be selected. Okay, and sometimes it's very hard to identify, to pick every member of a population as well. Sometimes you are interested to have a sample size of 10, and you might have gone up to from a population size of 1000, so it's hard to select 10 people from 1000 population size. How do we do that? So you need to define the population first. It could be the target population, and then you have to go for sampling population if you are doing both steps. So you need to define the population. Then you would simply mention the size of the sample as well. Okay. Once it is done, then you have to list, or you have to code the members of the population or the potential subject. Okay. As I said, you could simply write their names on piece of papers and you just put them in bag and select that number of pages from the box. For example, if you are interested in the study of 4th grade students, right, and they have demonstrated their problem behavior, so let's suppose we want to have that's the population we have simply defined, and then we move for a sample of size 10. Okay. So let's suppose this is a population, which usually call it potential subject pool, and we want to have a random sample from this population. So how do we do that? You simply select any one of them. You can simply say, okay, I'm selecting 3, Khalid, I'm selecting Shafi, I'm selecting Fayaz, and something like that. You can call their number as well, roll call as well. You can say, okay, 4 is selected, right? You can say 7 is selected, you can say 9 is selected, 10 is selected, then you can go 18 is selected, 23, 24, 27 are selected to have a random sample of size 10. Another example for this, you can see the red color names are selected as a sample point. So you see Ahmed is selected, Qadir is selected, Fayaz, and so on. You can say 1 number, 6 number, 10 number, 11, and so on are selected. So that's a sample of size 10. Okay, the next method technique used for sampling is known as systematic random sampling. In this case, what do? We basically look for we select every kth data point. Okay, if we are having a size sample size k, so you will be going for every kth data point. Like you say every 5th item in the alphabet list, every 10th name in the phone book, right? Or every student whose class number is divisible by 10 is selected for a sample, and so on. That's a simple system you have to introduce. It's quick, efficient, and obviously it will save your time and energy as well. Whereas disadvantages are not entirely bias free, because every individual may not have equal probability, because if you go for 10th individual, every 10th individual is starting from 5, so the next individual will be 15, the next will be 25, so the rest individual will have 0 probability. So system for selecting our subjects may introduce systematic error as well, and obviously cannot generalize behind population actually sampled. For example, if we have a sample size of 500 and the total population size is 10,000, so what do? We basically divide 10,000 by 500, that is approximately 20. It is 20 obviously, but sometimes if this is not a whole number, simple consider the smaller whole number. So every 20th individual is then selected. Now you can start from either number. You can start from 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever, right? So if you start from 5, so the first sample point will be 5, the next one will then be 25, and then the next one will be 45. So that is something called systematic way. You can start from 8 as well, you can start from 6 as well, you can start from 9 as well. You see in this case we have started from 9, so the first sample point is 9, the next sample point will be 29, the next will be 49. Every 20th sample point or data point is selected as a sample point. This is known as systematic way. If you go back to that sort of another data pool, so if you are interested in 20th individual, it's up to you. If you start from 2, so the first sample point is 2, the next sample point, if you are considering 20th one, that will be 22, the next one will be then 42, and so on. If you are selecting every 10th one, so if you've taken 2 as a first data point, sample point, the next one will be 12, the next one will be 22, and the next one will be 32, and so on. Okay. So another example is, suppose we have taken 8 as our first data sample point, the next sample point will be 28, because we are going for every 20th one, and the next one will be 48. Then the next one, if you go for it, that will be 68, and then 88, and so on, to have a sample size of a certain number. The next one is stratified random sampling. So in stratified, strata is basically derived from strata, which means a group. So for stratified sampling, what do? We construct first some groups in which every data point will be having of a certain characteristic will be in the group, and then we select one groups randomly. So in this case, you have to divide the given population into certain strata. Strata, as I said, that is a group, and then randomly you select one strata from those various stratas, and sample from each strata should be proportional. Okay. So the advantages are what? Better in achieving representativeness on control variable. Okay. And the disadvantages are difficult to pick appropriate strata, because as I said, the strata should have, individuals should have data points of all characteristic of all properties, and it is difficult to identify every member in a population. Okay. So in this case, if you are interested to have a random sample of size, let's suppose 10, so you will be constructing various strata of size 10, and every 10 individual will be having properties that is present in the population, and then you would simply select one strata from those manufactured or constructed strata randomly, and that will be the sample then. So you see, you have constructed different strata here. From this strata, you will be selecting one out of it, but you see, every characteristic should be there in every individual. Same thing here, the same thing here. Okay. So that's the way to do this strata sampling and stratified sampling. The next one is cluster sampling. I hope you know there is a difference between strata and cluster. The cluster is already made in a population in a geographical way, already present group, like university is one cluster. University is not a strata, and the same thing, town with a certain name is a cluster. It is not a strata. So in this case, we do what? We basically consider a certain region, a population, which would contain different clusters, and you select one cluster randomly. Okay. That is known as cluster random sampling. It is appropriate. When do we do that? When it is required for analysis. So you cannot obtain, if you cannot obtain a list of the members of the population, if the population is too big and you don't have a list, for example, you say there are 1 million students in a certain city and different universities. So you simply go for one university and say, okay, that's my sample. Would have a little knowledge of population characteristics. Okay. And if you have no knowledge of population characteristics, so obviously you cannot go for strata then. Population should be scattered over a large geographic area. So if these are the issues and you want to do a sampling, so in that case, cluster sampling is a better choice. You see, this is an example. You will have a large data, you divide, you already constructed region and whatever. So you simply pick one region randomly and you say, this is my sample. Why do we do cluster sampling? So it's more practical and less costly. Okay, you don't need those numbers. Simply say, this university, this city, this town, this house is what, this is my sample. So you don't need to do something. It's less costly. And obviously conclusions should be stated in terms of cluster. You would say, in this university, that is the problem, that is the analysis. So I could suggest this would happen to the whole universities are in that town or in that state. Sample size would be the size of selected cluster. Obviously, whatever the size of cluster would be, that would become the size of a sample. You don't need to mention size in this case. Okay, the next one, the mentioned random sampling that is known as multi-stage random sampling. This sampling can be done in multiple stages. For example, in first stage, you may select the simplest one. You select a cluster, or you may select a strata, okay, and then you do what? You select individuals from that cluster. How do we do that? Let me explain that. You see, let's suppose we have a population like this one. This is my total population, let's suppose. So if we have a cluster in there, this is one cluster, this is another cluster, okay, this is another cluster, this is another cluster. We may consider, let's suppose the size of sample is 5. Am I interested in size 5? So what would I do? I can do what? I may take one data point from the one cluster, cluster number 1. I may take from cluster number 2, from cluster number 3. You take one from here, 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 okay. So in this case, if you are selecting one individual from each cluster, so every cluster, there will be 5 cluster in the population. And if you change the number of clusters, they are not 5 exactly. So you may have an option of selecting 2 or 3 individual from one sample randomly. For example, again, if you are interested in 5 size sample and you have 3 cluster here, so what you can do, you may select one one individual from this sample, okay. You can take 2 from here, you may take 2 from here to have a size, to have a sample of size 5. This is another way of doing that as well. You can have a population like that, and there is no restriction on the number of clusters, okay, and there is no restriction on the size of cluster as well. So we select one cluster randomly. Let's suppose we have selected this one, and the only restriction is the number of the size of each cluster will not be less than 5. So you can simply select one cluster and then you go for a random selection from that sample, okay. From that cluster, you can have 5 individuals selected randomly from that cluster once you have selected that cluster. It's a simple way of doing that. You can extend that as well, like in the next example. You see, we can do it this way as well. If this is complete data, so what do? We first select a state, then we select some a district from the state, then we select one village from this district, then we consider one house from that village, and then you may consider individuals, a sample of size 5, a sample of size 6 from that house, if there are more than 5 or more than 6 individuals in the house. So this technique is known as multi-stage sampling. I hope you understood what I've explained. If you have any question, you can just write the question in comments box. I will come back to you. Thank you very much. And if you want to to encourage me to do these things, so it's best to subscribe the channel, or you may like the channel as well. So thank you very much. See you in next video.